LabVIEW is a programming environment and is a way for us to neatly program our robot based on the request from the drive team and the physical systems of the robot.
Our code is split up in two ways: the robot code, which directly controls the robot, and the driver code that conveys useful information to the drivers.
The robot code gets input from the drivers or autonomous scripts to control the systems on the robot.
Our robot code has many classes. Each class controls a different system of the robot. A class is a self-contained bundle of code. Generally, each class handles a single function of the robot. Classes are part of a design principle called object-oriented design, which is an industry standard for programming.
For example, the joystick class distributes the inputs from the driver's joysticks to the robot systems such as the shooter class and the drive class.
This is one example of what this allows us to do. You can see that the driver is controlling the robot. At competition, the Field Management System, or FMS, controls the flow of information between the drivers and the robots. The primary control loop is called teleop, where the FMS provides a data packet from the drivers to the robot. This is how our teleop looks. We combined our teleop code in the robot class to make it smaller and easier to understand.
Our teleop class is responsible for coordinating actions between the different classes, taking the joystick inputs and using them to determine what the individual mechanisms need to do, making sure that two conflicting actions don't happen at the same time. And shooter code gets called. Begin runs the beginning of a match. This reads information from our configuration file and initializes all the control systems. The configuration specifies parameters such as shooter velocity and motor control IDs. This allows us to tune the robot or even swap out major components on the robot between matches. A configuration file is something that can store values between matches. It can save user preferences, robot variables, and other data that needs to be stored. This makes it easier to change our variable values within the code itself. Autonomous runs during the first 15 seconds of the match. During this time, the drivers cannot control the joysticks and his actions must be based only on pre-programmed instructions and sensors on the robot. These instruction sets can be modified prior to a match to work with our alliance partners. Also, LabVIEW comes with a lot of helpful debugging tools that are easy to use and work very well with what we use LabVIEW for.
During deep space, there was a sandstorm during the first 15 seconds of the match, which blocked visibility of the field. The driver used the dashboard camera to safely drive off the platform and place a hatch panel.
Our dashboard is displayed on a laptop that's shown to our drivers while in a match. The dashboard communicates with the robot to get robot status or information to display our drivers. The dashboard displays information the driver needs to see, such as the temperatures of motors as well as the speed of some motors. The dashboard also displays the cameras. This is especially important so you can see what the robot sees, as the field is very big and you can't always see everything that's happening. The cameras also help for precision in interacting with various field elements or dropping various field elements.